Hello everyone. Today we are going to go through circular array rotation, which is a problem under implementation section of algorithm on HackerRank. So without wasting time, let us have a look on the problem statement. So here's the problem statement. I won't read it blind, but I'll just state the situation. So we have an array and we are supposed to rotate the array a given number of times. And after the rotation being performed, we are asked the value at a given index. So this is an example. We have this array and we need to rotate twice, that means 2 times. And after the rotation being performed, we need to return the value at the position 1 and at the position 2. So let us see how this is going to be performed. We have this array, the first rotation, this is the initial state. After the first rotation, we have this. How does it happen? So the rotation, this one came at the position first, which is here. The last one now go to position 0, and then the other one are just performing a shift 1 unit after. So this one will be at the last position, and this one will be at position n+1. So this is the result, and we are performing the same operation to have this array. Now at the end, we have our result array. Once we have our result array, we can now find the element at position 1, 0 base. So this is 0, this is 1. So that is why the element at position 1 is 5, and the element at position 2 is 3. So the result is 5 and 3. So this is a clear example of what you are supposed to build here. So now what will be our approach of solving this? So before I state the approach, if you're not yet subscribed to the channel, I really encourage you to subscribe to not miss what we are doing here. So, okay, our approach, we are going to solve this by using 2 different approaches. The first one will be exactly the screenshot of what we describe as example here. So we are going to create a result array that will be the array after the transformation being performed. And from the result array, we are going to look through and find the element of the queries. And the other one will be a slightly amelioration of the first approach. So without wasting time, let us go with the first approach. So the first thing we need to do will be to create a new array. So I'll call it new array, and then you do agree with me that the new array will be the same size as the initial array, just the position will be different. So I will create an array of size a dot size. So my new array has the same size with my entry array. So now from this, I can look through the array. So I will say, okay, a less than a dot size if I care. Now from here, I have my element at a position I. So I will say new array of I plus k, since we are going k time. So now the element that was at position 0, we find itself at position 0 plus k. Now we know that by performing the adding or the incrementation, we can find ourselves out of the range, like a size greater than the array. And if you are greater than the array, you start back at position 0. That is why we need the modulo operator here of the size of the array. So this one will just take a of I. Or if you want, you can even get rid of the curly braces because you have just one operation. Okay, so now at the end of this for loop, we have our new array. So the next thing we need to do is to look through the queries. And I'll have now a vector of result. I can put it here if I want. And if a second vector, the result that will return, that will be the element here I will return. And then now I need to look through the query. Now for each of the element of the query, what I need to do is that I need to say, okay, result.pushback of what do you think will be the right thing to put here? New array, exactly. New array of who? New array of the query element. the query of I. So yeah, I'm going through my array of query. Query of 0 is actually 1. This is my array of query. Query of 0 is 1. So this query of 0 will return me 1, and I will take the element at position 1, and then it's a new array of 1 that will give me 5. By the end of this, I will have my expected result. Let us run and see what it gives. You have a congratulations. Let us submit. You can see everything is green. Now, this is one nice approach of solving this, which is actually big O of n plus m, where n is the size of the array and m is the size of the query. Now, we can solve it also by getting rid of this. We don't always need to go through all the initial array. Why? Because we are not using all the element of the initial array. So by thinking so, you can just have one for loop to solve the problem, and that is what we are going to do here. So we are going to get rid of this, and we still need our result array. So I'm going to have it here. And for each of the element now, how am I going to organize myself to have the result? You will see it in 1 second. Let's see. So now, what we want to do here is a slightly different approach of what we previously did. So we took a given index, and we found where that element will be placed after performing a given number of shifts. Now we are going to take the opposite way. We are going to say, okay, this element, the element at position 1 was at which position at the beginning of the array. So now you say, okay, the element which is now at position 1 was at which position, and once you have the previous position, you can just take the element at that previous position from A, and then that will be the result. So I will just say, I will have here, I'll take a variable, say previous index. Sorry. So the previous index is naturally just the opposite operator. So it will be the query of I, which is actually the actual index, minus k, because you want the previous index. So we just perform the minus k. And then since we know that by performing the minus k, we can definitely find ourselves with a negative element. We don't want to have negative element. So we will indeed make the modulo operator here, the modulo operator of the size of the array. But you want to make sure that this result is actually a positive integer. And we know that since we are performing shift based on a size of an array, we can add the size of an array here. We can say, okay, a.size times, I will go with this. I will go with the biggest value we can have with the size of the array, 10 power 5. 2, 2, 1. Okay, I'll explain you this again. And then from this, I have my previous index. So this will just take A of the previous index. You don't need this, you can delete this. So this is the new approach I wanted to share with you. Let us run and see what it gives before I explain this line back, the previous index line. We have everything green. Let us submit. Everything green. So what I was explaining here is that, okay, so this is pretty clear. You perform a shift now minus k. Now, why are we adding this value? We are adding this value because we know that if you find yourself in a negative position, you really need to find the positive value of that negative value. And since we are performing a shift based on an array size, we are free to add the array size to our index any number of times we like. Just that because the modulo operator here will resize or reframe that value into the array size range. So we are now allowed to add this, and then we are adding 10 power 5 because we know that the maximum value of k is 10 power 5. So if you perform a shift, a big shift which is really really big, this value will be really 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 small in the negative sense. And by adding this, you have the positive value, and after performing the modulo operator, you find your index in the range of the array size. And from when you have the right index, you can now access to the value, and then you push to your array. So this is a slight amelioration. Now we are moving from big O of n plus m to big O of n. So this was my approach of solving this. I hope you do enjoy it. Feel free to leave me a message in the comment section if you have something to share related to this. See you on the next video. Ciao.